Solving a system of linear equations using elimination with multiplication and addition. So I have a system of equations here. Whenever I'm using the elimination method, the first thing I want to check is that both equations are in standard form, which these are. The next thing I want to look for is either x terms or y terms that are exact opposites. So if I look here at these equations, I have the with the x terms, I have the opposite part. This one's a negative x term, that one's a positive x term. With the y's, I don't have the opposites, they're both negative, but I do have a situation where this coefficient is a multiple of that one, which if you have that, where one of your coefficients is a multiple of the other, then it's a little bit easier, saves you a little bit of work. So even though these two aren't opposites, I'm going to choose to work with my y terms in this case. So if this one is negative 9y, the exact opposite would be positive 9y. So I need to multiply this bottom equation by something to change this negative 3y term into a positive 9y. So I would need to multiply negative 3 by another negative 3 to get positive 9. So negative 3 times negative 3 would give me this positive 9. But if I'm going to multiply this term by negative 3, I have to multiply every term in the equation, both sides of the equals, by negative 3. So this bottom equation is going to become negative 3 times 5x is negative 15x. Negative 3 times negative 3y is going to give me the positive 9y I was after. And negative 3 times negative 11 is going to give me positive 33 on the right side of the equals. Now the top equation, I already have an exact opposite here, right? Negative 9y is the exact opposite of positive 9y, so I'm just going to copy it over on or above the equation that I just wrote. So negative 7x minus 9y equals negative 11. So there's my two equations. Here's my exact pair of opposites. So now I'm just going to combine my like terms, doing kind of column addition here, straight down. So negative 7x plus a negative 15x is going to be negative 22x. The negative 9y plus 9y zeroes out, no more y terms, and equals negative 11 plus 33 is positive 22. Then if I divide both sides by negative 22 to solve for x, I'm left with x equals negative 1. Okay, now that I know my x term, I can take this negative 1 value, substitute it back into either of my original equations, and solve for y. So I'm just going to pick the top one for no other reason than it came first. So negative 7, but instead of the x, I'm going to substitute in that negative 1 value that we just found. Then minus 9y equals negative 11. So this negative 1 was substituted up there. So negative 7 times negative 1 is positive 7. Minus 9y equals negative 11. Solving for y now, I'm going to eliminate this constant term or zero it out by subtracting 7. And then keep my equation balanced by doing the same thing on the other side. Then I simplify. Negative 9y equals negative 11 plus negative 7 is negative 18. Divide by negative 9. And y is equal to positive 2. Negative 18 divided by negative 9 is positive 2. So the solution to my system here is x equals -1, y equals +2.